should you expect from all of this? This will be the first of hopefully many RU for Scuba virtual training courses. We're gonna have 60 minutes of presentations by 12 members of the RU for Scuba staff. And an important point here is realize that this is supplemental material to the Science of Diving specialty, the SSI specialty. You still need to do it. You need to go online and go through all of the online digital kit materials and take the final, which I know a few of you already have. But we want to see you all finish. We're going to be muted during the presentation, but as you can see, as we kind of look down to number 3, we're going to have an optional after party. So at that point, we're going to open it up and we're going to have questions, and maybe you can make Jim do some hard math. That'll be fun. So what should you do? Let's roll your cameras, interact with your camera. If there's something that you really agree with that we're talking about, you know, I don't know, give a scuba sign. If you're not really getting what we're telling you, you know, give us the I've got a problem sign. So we're going to tell you about some other SSI specialties also, and you can then maybe think about where you'd like to take your learning from here. And we'll be putting a schedule together of some of those specialties as well. So, and we want your feedback. So this is, as I said, the first virtual training course that we've done. So we certainly will value your feedback and try to incorporate everything you tell us. So with that, it's got to be done. No? All right, so this today is all about diving physics. So this entire session is going to get into a lot of really interesting things, and we have 3 other sessions that are planned. So we got diving physiology and decompression theory and the components of the total diving system and accessory equipment. So this week and next is are the 4 sessions that we've got covered for you. So I think the next thing we're going to do is we're going to turn it over to Jim, who's going to just give you a brief overview of the RU for Scuba shop. Jim?
All right, thanks, Dave. So first of all, welcome everybody. So for those folks who have dove with us before, welcome back. And to our new friends who are joining us, welcome. So RU for Scuba, Don Abel and I own it. We have 12 instructors on staff. We're a little bit unusual in dive shops in my experience because we actually go diving. It seems that a lot of dive shops get trapped into the whole training thing, but we have a very active dive schedule. And the reason I mention that is a lot of people have been sending emails in saying, what are you guys going to do? When's the boat going to go in the water? All of that. And the honest answer is, we don't know, right? As you know, it's very hard to social distance on a 28-foot boat. Right, so we really don't know what's going on. As soon as we're legally allowed and we all feel safe, we're going to get underwater. So with the quarry, we were planning originally to start at the beginning of June, and my gut feel is that that's not going to happen. But hopefully things will open up as July gets on. We have a couple of trips scheduled up to Tobermory, up to the Thousand Islands. Local trips, etc. So best thing to do is just check the website under the calendar area, right? I think with that, Dave, I believe it's back to you. I'm sorry, no, it's back to Jeff. I'm sorry, I should look right at your screen.
Great transition, Jim. Thank you. Good evening, everybody. My name is Jeff Munn. I'm an instructor with RU for Scuba. I'm also alternate boat captain for the boat that isn't going on. Jim, I got a great suggestion for you, is that you can call Cuomo and tell him Jeff feels that diving is essential. So
well, there
we
you
should
go.
be able to go out on the boat. Good. Right?
Well, Jeff, I do have to say, the dive trade organization, DEMA, Dive Equipment Manufacturers Association, tried arguing with the government that if campsites were open, scuba shops should be open. They did not win that argument.
COVID underwater.
Yeah, that's the exact point.
So tonight I get to introduce to you gases relating to diving for everybody. And basically the gases relating to diving is the air that we're breathing all the time. And Dave's going to handle the slides here. And as you can see on the screen, that this is a little bit of the breakdown of the gases that we breathe. And it's pretty much same percentages no matter where you go in the world, where you have nitrogen rounding it off roughly 78%, oxygen rounding it off to roughly 21%. That makes up 99% of all the breaths that we take in into our lungs. And you have a very small percentage, argon's almost 1%, and then very small percentages of other gases, carbon dioxide, 0.03%, and all the others make up 0.02%, which you have carbon monoxide, helium, hydrogen, krypton, neon, and radon. So these are very small amounts, but to focus here on recreational diving, really what we focus on is the two biggies, nitrogen and oxygen. And I'm not getting deep dive, so to speak, into all of this in my presentation, but I just want you to start thinking about this because it's great stuff to learn and master and understand these gases and what they do and how they affect your body while you're diving. Nitrogen is the most prevalent gas that we breathe when we're taking breaths from our atmosphere, or when you're just breathing air, natural air gas in your tank. Nitrogen is interesting because it has a propensity of diffusion into our body tissues. Well, why is that an issue? Well, nitrogen has a very anesthetic effect, which can cause nitrogen narcosis, or Jacques Cousteau, I think, came up with the term rapture of the deep, where you feel just everything is great, and that feeling of euphoria, and it can lead to problems. And you'll learn more about this in diving physiology as you go through reading and studying on science of diving. Another thing with nitrogen, and you're going to learn more about this, is the partial pressure of nitrogen. If it is greater in our body than external partial pressure, then bubbles can form. And bubbles forming inside of your body is not good, and that can lead to decompression sickness, which is another bad thing for divers. So learning about nitrogen and understanding the effects and recognizing some of the symptoms of these things can help you be a better diver, can help help your buddy when you're diving. Very good to master and understand all there is about nitrogen. The other gas, which is very prevalent in diving, or in the air that we breathe, is oxygen. Basically, that is the gas that we need to stay alive. Not enough is hypoxia, and that can lead to unconsciousness or death. Too much of it is hyperoxia, which can lead to pulmonary or central nervous system toxicity. Interesting to note that sometimes, and I don't know if anybody is nitrox certified, but the air we breathe being 21% oxygen, sometimes if you get nitrox certified, which I highly recommend everybody go and do this, if you're not already, become nitrox certified, because then the air that you're breathing underwater can be greater than 21% oxygen. It could be all the way up to 40% oxygen. And some of the cool things with that, you go away on a trip and you're doing repetitive diving, it cuts down on your surface interval. Also, with a lot of repetitive diving, just makes you feel a little bit better. And you'll notice people on the boats or where you're diving that they're going to have a tank with a green-yellow band around it saying nitrox. And you say, what is that? Well, they understand and discovered the benefits of nitrox, and I strongly recommend learn about oxygen and take that nitrox test or class. You can get it from Jim. It's online stuff, a little test, and some practical stuff on testing your tank, and you're good to go just to be able to learn about that. So it's a fantastic thing to learn a little bit more about the oxygen. And the other gases that we run into, you have your deep dive mixes, which is helium, which often is used for trimixes for very, very, very deep diving, way deeper than what we experience at our recreational limit of 130 feet. You also have hydrogen and neon, which they've been experimenting with to use for deeper dives. Again, a lot of this is to displace the nitrogen and the effects of nitrogen in our body as it gets diffused into our tissues. So, but with recreational diving, we're not going to experience much with these gases. We also have argon, which argon often is used for dry suit inflation gas because of its low cost and insulation properties. We don't use it for anything breathing because it is also very narcotic to humans to breathe in argon. But if you're going to think about dry suit diving, and I highly recommend you think about that in the Northeast here. I just got a dry suit this year, and I'm mastering the dry suit. It's great because around here, you get below the thermocline, it's a little bit cold. And it is just unbelievably comfortable having the dry suit in the warmth inside of your dry suit when you're down in 50-degree water. It's fantastic. So it really expands what you can be doing diving in the Northeast here. We also have carbon dioxide. This is the gas that we're constantly breathing out. We're trying to get rid of this. It's also considered a synergistic gas, which means that it can also lead to other bad things if we get too much carbon dioxide in our system. It can lead to decompression sickness. It can lead to oxygen toxicity and also narcosis. So learning and understanding about carbon dioxide is important. The other gas that I need to mention also is H2O, or water vapor. It's good to know and understand about this because moisture in our air delivery system can freeze. I mean, if you look at, you ever take a bottle of air that you're going to go diving with, and you crack open that valve really quick, you notice really fast that that valve gets cold fast, and it could lead to freezing up your air delivery system. So just to learn and understand that. But then on the other hand, too little water vapor in the air that you're breathing can also irritate your throat and your sinuses. So this is a little bit of a broad brush on a lot of the gases that you're going to experience in your diving. And all of these gases, one kind of interesting thing is there are laws pertaining to all these gases. There's several gentlemen that over the years have done a lot of research. A guy named Boyle with Boyle's Law, Charles with Charles' Law, Dalton's Law, and Henry with Henry's Law. The interesting take on all of these is it has to do with three things: pressure, volume, and temperature. And what happens to a gas is the temperature goes up or down, or pressure goes up or down, or volume goes up or down. So to understand and learn about these is stuff that you're going to be using every single day when you're diving, from when you jump in the water and you feel pressure on your ears. What is going on there, so you understand it and how to affect that. Using these different laws and understanding, how to make sure that you don't have problems with too much nitrogen or narcosis. So it's great to learn and understand these. I'm not going to get into the in-depth on all of these laws, but I'm going to turn it over to Jean, which is going to start off on Boyle's Law, and Megan and Joe then are going to get into all the other laws here and give you a little bit more of a deep dive, so to speak. So Jean, I'll let you take it from here, and you can do a little introduction and start in with Boyle's Law. Thank you.
Thanks, Jeff. Appreciate it. Just a little bit ago, I was somewhat frustrated with snorkeling because I found that if you're going along and you see something of interest and you kind of pop down to take a look at it, you just never really had enough time to investigate. Then you come to the surface, grab a mouthful of air, and you go back down, it's gone. You've drifted, you can't find it at all. So in 1971, I got my open water certification, and after having a great deal of fun at the National Boy Scout Jamboree in 2010, I pursued more training and achieved an assistant instructor rating in 2016. Now, most of the time I dive in the Adirondacks. And this is a great place because at high noon, you can enjoy a shore dive, an advanced dive, a cold water dive, and a night dive all at the same time. Now then comes along RU for Scuba, who have successfully spoiled me with wonderful warm water dives in places like Bonaire and the Grand Caymans. I still enjoy a dive of any kind anywhere, but clearly I long for those wonderfully orchestrated luxury dives by RU for Scuba. So if I could have my first slide, please. Sir Robert Boyle. Now, I feel quite confident that when this Anglo-Irish natural philosopher, chemist, physicist, inventor set forth his physical-chemical relationship of a gas's pressure versus its volume in 1662, he was not thinking at all about scuba diving. Boyle's work was originally formulated from a hypothesis by Henry Power the year before, and just simply states that a gas, when contained in an elastic container at a constant temperature, would have its volume altered inversely to the change of pressure. Well, this is kind of obvious. If one were to look at a balloon, the more pressure you put in the balloon, the larger it gets. Now, much as that is obvious to us, since a balloon wasn't invented until 1824, I don't think Boyle had that as a go-to image, but I digress. Boyle's law simply showed mathematically that pressure and volume are linearly related. So if you double the pressure, let's say on the outside of our balloon, it will cut its size in half. Next slide, please. Now, I am certain that what you're looking at is just absolutely fascinating. And this little talk that I've given so far is probably just bringing tears to your eyes. Well, let's just get to two major applications that Boyle's law does to make our diving safer and more enjoyable. So if we just take a gander at this chart, we see all the math has been worked out for us, and there's something I want you to just take home. Notice that at the surface, we have an atmospheric pressure, that's the ATA, let's say of 1, just making a unit. The left side there, that SW is salt water, so that's feet of salt water. So it's 33 feet. We have doubled the atmospheric pressure. We went from 1 to 2. And if we look on the right side, you'll see that our density is doubled, but the volume has gone in half. Now, we're not talking about your volume. We're talking about a gas that's in an elastic container. So this is not the gas in your tank, because that's definitely, thankfully, not elastic. And here's the interesting thing. We want to go and just see, well, let's double that again. Well, if we go to 66 feet, we haven't doubled it. We have to go to 99 feet before we doubled where we were at 33, so that we cut that size in half and we come up with a quarter of the volume. Even after we go to 132 feet, we're still only at 1/5. So you say, well, geez, that's great, so I can go to far depths and not be affected. Well, let's look at it the other way around. If you see, this is what happens when you go off script. Next slide, please. The most important lesson to be learned is from your ascent. So now you realize that as you go down, your lungs are filling up with compressed air, right? In order to overcome the pressure on you and not collapse your lungs, you need, because you are a little bit flexible, your regulator gives you compressed air to maintain that pressure and have your lungs inflated and work correctly. But now think about when you're down, and if you do something really stupid like surface while holding your breath, because as we all know, there is one thing that you never do is hold your breath, ever. If you were to do that, think about this whole thing in reverse. As the pressure is cut in half, the size of that container, in this case, the alveoli of your lung, will become double. Something of this sort will cause hyperextension, and that will be a fatal error. People will not live through that. This diagram shows a little more about how things double. So it's 33 feet to 99 feet, and then from the surface, 231 gives you the 8 times. Now, as we mentioned, the pressure needs to be compensated. And here's where your regulator comes in to supply more air to inflate your lungs. And all of these things we're speaking about here, this being the simplest gas law, are feeling that temperature is maintained. There's no change in temperature. We all know as we dive, the temperature does change, and here's where the other gas laws come into effect and bring a little more fine tuning. So with that, I'd like to hand this off to Megan.
Thanks, Gene.
Okay. Megan's starting her diving in 2013 and was hooked after a single dive. She enjoys shipwrecks from the St. Lawrence and all the way down to the warmer climates. She loves teaching people and others the experience of diving and also specialty courses like rescue diving and React Right. Sorry for the pause. Megan, it's all yours.
Thanks, Gene. Hi, everyone. So I get a couple of gas laws, and to put it in perspective, there's a lot going on with gas laws and a lot that goes into it. And I am no SSI writer. So let's just cover some of the basics and how they apply and how you're going to feel their effect on your diving. So Charles' law. Charles' law relates volume and temperature to each other. It kind of ignores everything else and just says, let's look at these two. And volume and temperature go hand in hand. So the colder it is, the lower the volume. The warmer it is, the higher the volume. One of the primary ways I feel this is when I go scuba diving in the winter. I like to go down to Arnie's Marina in Sodus, jump in their bubbler area, and look at all the cool cold fish that have nowhere to run and don't care. You can see some pretty amazing bass that just hanging out by the bubblers, don't care that you're there. So when I go into the water and everything shrinks because it's cold. But I get a good warm temperature, I add air, nothing squeezing too much, and I go on a nice dive. I come out, if I don't let my seal open pretty quickly, I'm gonna get squeezed and vacuumed into my dry suit because all of the air that was in there keeping me warm and dry is now getting colder because the air around me is colder than the water I was just in. So it's going to create a suction because those air molecules that are trapped, keeping the water out, is now trapping me into my dry suit. So think about that. Volume gets colder, or the volume of air gets colder. Temperature goes down, things get squeezed. Also, think of a, nope, that's part of the next one. So the next is Guy Lucas's law. He recognizes pressure and temperature together. So he kind of ignores the volume aspect of it. He says if your container's sealed and you increase the temperature, your pressure goes up. All right. So you have a nice cold can of soda. It's kind of squishy. No problems. And then if you were to heat it, it's going to expand the gases in that soda, carbon dioxide, and it's going to make the gas firmer or the can firmer, and you're not going to be able to squeeze it. Jammer, like a reactor. There you go. See, diving and gas laws are everywhere. So your pressure goes up as your temperature goes up. And then next slide, please, Dave. Someone commented, looks like you could combine all of these. Yes, you can. So that's where we get the general gas law. And this is kind of where we take several guys' interpretations and laws and say, hey, let's put them together. What does this all mean? There's a very nice formula displayed on your screen that if you have an unknown, you can plug other variables in and you can figure out what one of your unknowns is. Great math equation, feels like you're back in high school. But don't worry, we'll put it into perspective for you. So let's go diving. You're in water that's 75 degrees. Your pressure and volume are at one thing, and your temperature, like we said, was at 75. You're going to go down through the thermocline. Oh my goodness, it dropped to 50 degrees. Hope you're wearing your dry suit. And then your pressure's increased. All right, you're going to feel it on your ears if you haven't been clearing all the way down, or you're going to feel it pretty quick. You're also going to feel it on your body. Sometimes a few feet is enough to feel the squeeze of the water. Sometimes people aren't as noticed to it, but it's felt on your tank and what you're breathing on your lungs. All right. And then you get into the next law, which is Henry and Dalton's law with Joe Perry. All right. Joe is an amazing dive buddy. He was one of my first dive buddies in the St. Lawrence. Let's see what. He began his diving experience in Jamaica while on vacation in 2004 under the PADI training program. Once back home, he talked with the local dive shop and preferred the RU for Scuba philosophy. He's expanding his training to have progressed to instructor over the last years. His wife has no interest in diving, and his 16-year-old son is interested. About half of his 275 dives are Caribbean-based. Kind of jealous, Joe. My number's up there, but not in the Caribbean. And he is an industrial electrician and HVAC installer in his spare time. You have spare time, Joe? You're a diver. There's no such thing.
Now, Joe, you don't get to do commercials for your HVAC side hustle, okay? This is a diving side hustle.
I'm winding that down. Got to have more time to be diving. Thank you, Megan, for the introduction. Good evening, everyone. My name is Joe. I'm another instructor here at RU for Scuba. I want to thank you for your participation today. As Megan said, I've been diving for over 6 years and a little over 275 dives. Rescue certified with several specialties under my belt. All those been just enjoying expanding my knowledge. My topic of discussion today will be on two important gas laws as they pertain to diving: Dalton's Law and Henry's Law. Dalton Law was named after John Dalton, physicist who in 1801 discovered the following relationship about gas pressures. For any given gas, pressure total is equal to the sum totals of the partial pressures. It sounds simple enough. Why is this law important to scuba divers, you might ask? As Jeff already mentioned, breathing gas is made up of 78% nitrogen, 21% oxygen, and 1% of other gases. For sake of this discussion, we'll only consider nitrogen and oxygen components. Standing on the seashore or in a boat before you're ready to enter water, you're at 1 atmosphere of pressure or 1 ATM. This is because the column of air resting on you has a weight associated with it. This can also be measured to be 14.7 psi typically. We don't ever notice this as we're acclimated to it. It's what we consider normal. As divers know, as we descend into the deeper depths, the pressure also increases on our body and on our equipment. This is a direct result of the additional water column above us pressing down upon us. As Dalton Law states, as we descend, the pressure increases proportionally on the breathing gas that we are using. At 33 feet, there's twice as much pressure than it was at the surface, and increase another 1 atmosphere for every 33 additional feet incurred. At 130 feet, we'd be about 5 atmospheres of pressure. Keep in mind that the partial pressure of nitrogen and oxygen is also in our delivery system is increasing. This actually begins as soon as you start your dive. Oxygen can and will reach a point where it becomes actually toxic to our body's cardiovascular system. Over decades of diving, it's been determined that a safe partial pressure for oxygen is between 1.2 and 1.6 bar measurements. Most divers prefer the 1.4 bar number for calculation purposes. Fortunately for us most of us use dive computers. This is what they're typically defaulted to if we don't alter them ourselves. Now keep in mind, recreational divers stay above 130 feet, even with a deep training certification. In order to reach a toxic level of oxygen, you'd have to be down at 187 feet. So it's typically not even a concern for recreational divers, just something to be aware of. Increased partial pressure of oxygen plays a role on the central nervous system. As mentioned before, oxygen becomes toxic to a diver when partial pressure is too high. This can result in changes to vision, dizziness, vertigo, and seizures, among other characteristics. Keep in mind, though divers' personal health and experience will come into effect in every dive, some divers could be more affected by this than others. Even the same diver under different circumstances, different environmental conditions, is going to experience a different dive. We should be aware of Dalton's law because the effects may appear in our dive buddies or fellow divers as well. Keep in mind that we are assuming that the breathing gas is compressed air for all these examples. If you were to increase the ratio of oxygen to nitrogen by diving with nitrox, you need to adjust your dive profile to account for increased oxygen content. This will be covered in greater detail if you were to take the nitrox course offered here at RU for Scuba. This, by the way, is a very popular class. It does increase your bottom time. It's very popular, very safe. Tech diving, if you chose that path in the future, will expand greatly on Dalton's law and Henry's law as it applies to scuba and its effect on divers. Now we'll talk a little bit about Henry's law. Henry's law states the amount of gas that will dissolve in the liquid is directly proportional to the partial pressure of the gas given the temperature and molecular movement, agitation, of the liquid are constant. What this means is that some gases are more soluble than others. Your blood will absorb the different gases at different rates. Conversely, you will off-gas at different rates also. And understanding of Henry's law is important because upon descent, supersaturation could occur. Again, this is unlikely if you do your proper dive profiles and safety stops, but we just need to be aware of these conditions. So if you're not practicing safe diving profile, these could occur. It would cause physiological effects. Example of this could include decompression sickness and deep water blackout. Again, please hold any questions till after webinar is concluded. Next up, I'd like to present Daryl Jacob Moore. Daryl has been my dive buddy for several years. That being said, when we dive on the same buddy over time, you learn what their normal is, and that's why I try to watch out. And you see anything abnormal, think about these laws, gas laws, if somebody violated them or maybe had an issue with it. That could be a reason for them being a little bit off kilter and stuff. So it's just a reason to kind of look outward at your fellow divers. Thanks again, and I'll hand this off now to Daryl.
Thank you, Joe. Good evening to everybody, and thank you for being here and help us all make a connection in these difficult times. So I'm going to take a couple minutes and talk about buoyancy and Archimedes' principle. First slide, please. And there we have it. And next, okay. So buoyancy, something we all, we work with it from the time you might hop in the pool in an open water diver class, all through your diving career. Buoyancy is part of it. And the force by which an object floats or sinks, that's buoyancy. So there are three kinds of buoyancy. There's positive buoyancy. If you take a ball and throw it in the swimming pool, it's going to float. Good evening. If a ball in the pool will float, and if you take the ball and you push it down into the pool 2 or 3 feet down, when you let go of it, it's going to come back to the surface. That's positive buoyancy. It's rising out of the water column. Negative buoyancy, if you take a stone and throw it into a pool of water, it's of course going to drop to the bottom. Negative buoyancy. And neutral buoyancy is what we all try to achieve. A well-trimmed, weighted diver would want to be in the water column and neutral, not rising nor falling. And the other way to look at this is that if you take take an object and put it down into the water column, it won't rise, it won't fall. It'll stay right there. So that's buoyancy. A gentleman came along, next slide, please. And like Boyle, he wasn't thinking about diving, but Archimedes, he was over 2,000 years ago considered one of the greatest classical mathematicians. He also was a physicist, engineer, inventor, astronomer. It seemed like these guys did everything. And even Galileo called Archimedes a superhuman. So pretty impressive guy. And what he did for us is he wrote a 2-volume treatise called On Floating Bodies. So what happens when you put an object in water and how is it affected? So what he said was that a body immersed in a fluid experiences a buoyant force equal to the weight of the fluid that it displaces. And so in this diagram, number 1 on the left shows that you have the weight of the atmosphere, 14.7 pounds, pushing down. You then have the weight of the water coming up on number 2. What happens when you put an object in water? So you place the boat in, you have the same weight of the atmosphere pushing down, you have the weight of the water pushing up. However, you now have a displacement that's happening down into the water. And that displacement, the weight of that water that's displaced, is the buoyant force. So next slide, please. One of the things that, another way you might look at, and I kind of alluded to it a moment ago, is density. So that if something, if something is denser than the liquid that it goes in, it's going to drop. If it's not as dense, it'll float. And if it's equal to the density, then it's going to be neutral. So one of the things Archimedes assumes in his formulation is that the object going into the water won't change weight and it won't change volume. But this isn't really the case with a diver. As you know, when you go down into the water column, you descend, pressure increases, your exposure suit, your wetsuit compresses, so your volume changes. So we have to be able to counteract that to obtain neutral buoyancy. One of the things we do in our perfect buoyancy course is we start to look at some of the aspects of how to achieve that neutral buoyancy. So proper weighting and trim is something we look at. We have a buoyancy control device that helps us balance the weight and so on to help us in the water column to become neutral. Something you need to always remember too is that you have a natural BCD, and that natural BCD is your set of lungs. And on average, a set of lungs could have, with a full breath, 6 to 14 pounds of lift. Now, if you think about a BCD that you buy commercially, depending on the size and style, you can have 20 to 50 or 60 pounds of lift in the BCD itself. So let's say you get the weight balanced well for yourself. The BCD has you put enough air into the BCD to counteract that. You're feeling pretty good. You have to remember that your lungs are going to provide you lift and also have you drop off once you exhale. So this is why we talk about having a slow, long inhalation and a slow, long exhalation to maintain neutral buoyancy. Finally, something to think about, that your scuba tank, an 80 aluminum scuba tank, has in it from full to a 500 PSI when you might be getting back on the boat. It has over 5 pounds of air in it. So you need to compensate for that at the beginning of the dive so that at the end, you're not just popping up to the surface. So again, buoyancy control is Archimedes, and Archimedes he goes on every dive with us. So next slide, please. So a few of the other instructors have talked about trips they like to take, and I do too. And here's a buoyancy example on a wreck in Roatan. And on the left slide, you have one of my favorite dives. We're on the descent, and I happen to be one of the last ones going down the mooring line and letting go to go down to the wreck. So we're all negatively buoyant. You can see that the divers are at different levels and air bubbles coming up. And what a beautiful view that was from the top. Negatively buoyant. So we're descending in a good way down to the wreck. In the right-hand picture, you have co-owner Jim, and you'll often see him on these dives, often the first one in the water and the last one out of the water. And he is neutrally buoyant down at the wreck. Not moving up, not moving down, just comfortable. And we're down at about 100 feet and feeling pretty good. And so there we have it. We returned, we became positively buoyant. We controlled the ascent in a good way, no more than 30 feet a minute. And so it was fun and good. And that's buoyancy in Archimedes. Your next presenter tonight is Nick, and Nick became certified open water diver in 2014. He also enjoys traveling to various diving destinations, in particular Bonaire, Grand Cayman, Florida. He became an SSI instructor last year in 2019, and I'll turn it over to Nick.
Daryl, thank you for the introduction. Good evening, everyone. I'm going to be discussing energy in the underwater environment tonight. The first one I want to discuss is light. So there's four major factors that light influences the first. And essentially, light just here. Play gap in air through water. This is ambient light. There's less ambient light the deeper you go. And one way to kind of help with this would be using a light as you're diving on deeper dives. The third factor is turbidity, and this is particles suspended in the water. These particles could be algae, pollutants, silts. I think we've all experienced some sort of turbidity when diving in Lake Ontario up here. And the darker the particle is, the less ambient the light. And these particles can make it difficult to see, kind of like, or it's the same effect that fog has on car headlights. The last major factor of light is absorption. So again, the deeper we go, colors change. Specifically, the warmer colors of red, orange, and yellow, they kind of begin to fade more towards gray. You might have noticed that diver carrying a GoPro while diving has some sort of corrective lens cover on it, normally red or orange. And this is just to kind of bring back in those warm colors that are filtered out as you go deeper. Next, I'm going to touch on sound real quick. So sound travels approximately 4 times faster in water than in air. And you may have noticed on one of your dives, you'd hear the sound of a boat passing. Sounds like it's passing right overhead, and you'll be looking around, but you can't see anything. And it's most likely because this boat is actually further away, but due to sound traveling faster in water, it appears to be closer. The next energy I'm going to touch on is heat. And the first one would be conduction. So conduction is is heat transfer through direct contact. And for a scuba diver, this is a major form of heat loss due to the fact that divers are in direct or semi-direct contact with the water. And water conducts heat much better than air, which causes the diver to rapidly lose heat when they get in the water. One way to counteract this as a diver would be to use a dry suit, and that air in the dry suit serves as an insulator. The next one would be evaporation. And so as water evaporates from an object, heat is lost. And this takes place on the diver's skin, or even as water evaporates from the surface of a wetsuit. Convection. Convection is the transfer of heat through the movement of gases or fluids. A pretty good example of this would be if a diver has a poorly fitting or not wearing a wetsuit at all, and the warmer water surrounding the diver rises and is replaced with colder water, and that increases the rate of heat loss. And the last one would be radiation. And this is, if you guys have ever, stood next to your stove, you can feel the heat radiating from it when it is on. So all divers, they radiate heat from their body to the colder water environment. And this is also another way that a diver loses heat while diving. So just kind of a brief overview of different energies that you experience underwater. And now I'm going to turn it back over to Jim.
Hey, there you go. I dropped for a few seconds there. Sorry that I took a few seconds to come back. So a couple things I wanted to touch on about specialties. So the Science of Diving class has an interesting history. So back in the 50s, when diving first gained popularity in the recreational community, at least, you really needed to find a mentor to teach you how to dive. There weren't really dive manuals. A lot of your gear was homemade, etc. And the 60s came on, and more companies got into the sport. Gene probably has a lot of the dive gear from then. But then in the 70s, the dive training organization started, and they aimed their classes around university semesters. So it wasn't trying to find somebody who was a diver that would take you on and show you the ropes, to a more traditional classroom session. But with a university session, those classes are 13 or 14 weeks long. So they spent a lot more time on the education side of things. So what we know now as Science of Diving was really the open water diver materials for class. Certainly there's a lot of water work, etc. But you'd be going to class, 1 or 2 nights a week for 3 or 4 hours a session. You would sometimes spend time in the pool, but you'd definitely be in the classroom. So just like the Science of Diving class was the very kind of basics of open water in the 70s and early 80s, right? A lot of these specialties that have existed were part of that as well, right? And so at one time you're either a diver or not. And then in the early 90s, the training organizations got together and decided to say, you know what do people really need to know in order to dive? Right? Well, that's what the open water course is now. And it doesn't make any difference which training organization that trains you. All the reputable ones are members of the Recreational Scuba Diving Council, and it's the same standards, right? It really no difference. It's the materials may be different, but the material that you're learning, the information you're learning is the same, right? To that effect, then, where there's some differences around specialties and how specialties are handled, right? So while we're in this period of time where we have to social distance, we thought that people wanted to take some additional classes. There's some specialties that lend themselves naturally to being taught virtually. So the science of diving class is really being taught online, and we're supplementing some of the materials, right? But we can teach some of the ecology courses, the fish identification, coral identification, etc. We actually teach that in Zoom sessions. In the diver stress and rescue class, we've had several people sign up recently. In that class, there's the traditional rescue component, which is a hands-on in water work. But I think the more important bit is around the stress part, recognizing stress in yourself and others and how to deal with it. And there's a lot of role playing there that you don't have to be in the same room to handle. Equipment techniques, we're going to touch on that. I believe it's next Thursday when Don goes into some of the equipment in detail. We're actually rip a reg apart so you can see what that's like. The equipment techniques course goes into that in more detail, etc. Nitrox is basically all online nowadays. There's 2 levels of that course. If you want to use pre-blended nitrox up to a 32% mixture of oxygen, that can be done 100% virtually. The standards were changed to support this social distancing we're doing. One of the differences that SSI offers, though, is their awards. Right? Most training organizations, you come out of an open water course, then the next course you would take if you want to progress on would be an advanced open water course. And then it's on to rescue, and then it's taking some other specialties and eventually to master diver. What SSI does says it's nice that you take classes, but you also need experience, right? So they have a rating called a specialty diver. So if you take 2 specialty courses, and science of diving counts as one of those, and you have at least 12 dives under your belt, right? You become a specialty diver, right? For advanced open water diver, you need 4 specialties and at least 24 dives. Master diver, 50 dives, the 4 specialty dives, and stress and rescue. And then Dive Guide is the first professional program. So those ratings that you can earn can be based on past experience. It's not like you have to get 24 dives from today. If you have 50 dives already, and this course would make your 4th specialty, right? When we process the certification, you will automatically receive an advanced open water recognition as well, right? And then with that, Dave, I think we are opening things up for questions, if I remember correctly.
Well, Jim, first, let's talk about what's coming up. So Thursday, we have diving physiology. So make sure you join us for that. And today, we really enjoyed presenting this prepared material for you, but I'm going to give you an out. So for the after party, if you really aren't interested maybe in doing math problems or kicking back and just kind of having some fun with the RU for Scuba guys, you know, don't feel like you need to stick around. The prepared material is done, but do think about these specialties. There's a lot of cool things that we can work towards if we can get a good handle on what you want. And I think that's it. So at this point, we're going to unmute everybody.
We're all unmuted.
Yay.
Yes. All right. So for the after party, this is where you get to ask questions and we can maybe provide answers, or if you just want to talk about something cool that you've experienced, we'd love to hear about it. One thing I was thinking about when Nick was talking about absorption, we actually have slates that have the different colors of the rainbow kind of printed on them, and as you dive deeper, you can see those colors just one by one.
If I find one,
start to go away. It's pretty cool. And the way you can combat that is with your flashlight, with your torch, right? So it's another reason to have a light with you, because it's not just about being able to see in dark places. It's about bringing the color back to things that you want to look at down there. Okay, any questions? Somebody's got a question.
I have a question. Seeing that Patty and I are doing this together, do we have to do it separately on the SSI, or can we do it together on the SSI?
Well, Well, you can do it together, except for the final exam. You have to each do your own final exam. So you can certainly watch it together, etc., and then say we do it under Patty's account, Bert, you just need to go to the end and answer your own final exam, and then you can have bragging rights of who scores higher.
Sounds like trouble.
I've gotten to know him a little bit. I see a relationship dynamic there.
You know, Jim, maybe we ought to have Alan do some dive table stuff for us.
That would be great. Yeah. So okay. So that was an inside joke. So so Alan contacted us today and said, "Hey, I'm working some of these final exam questions about the dive table, and this just doesn't seem right." You know. And then he went to the trouble of like taking the table and like putting red lines on where he's intersecting things and all that, and he was working it correctly. The issue was Alan was doing on a PADI table that has more pressure groupings than the SSI or the Navy table that SSI uses, and so of course there was no way for him to get the correct answer using the PADI table. So anyway, so he was good sport about it. So. But it worked out in the end.
He's got it.
Yep.
So Jim, I see a question here from Pat about how you get your PADI certs to be recognized by SSI.
Good question.
There you go. Would you like me to handle it, or would you like to answer it?
I would like you to handle it.
Okay. So yes, what you need to do in the SSI account, there's little information about you, like your email address and that type of thing. And under there's certifications, and then when you click on that, well, you know what? Here, why don't I just show everybody?
There you go.
It'll be a lot easier. So, Pat, do you mind if, and I better not show your information because it may have your phone number.
No, you can. There's nothing in it, so go ahead.
Oh, okay. So let me just find you first. Course manager, science of diving. Pat.
It's just got my bank account and password in there.
Password, social security number, yeah.
I've got my notebook right here.
Social.
Right.
Code.
And then you hit research search. Hold on a second. Pat, last name. I don't care about training center and all that kind of stuff. I'll show my screen in 1 second.
I'm in there as Patricia. Maybe that.
Okay, no, I got it. So, no, there were several Pats apparently. You will stop the other screen sharing. Yes, I will do that. All right, share. All right, so you'll see something like this. I get to see everybody, but you'll see something like this, right? So there's a green button here that has the words non-SSI next to it. It may blow that a little bigger for people. All right. So add non-SSI C cards to user profile. When you click on that, that is where you add non-SSI C cards to the user profile. And
You got to go to the website. You can't do it in the app, right?
I've never done it in the app. I think you have to do it on the website.
Okay.
Right. And so it says what it is, you know, where you are, what certification is, etc.
Oh, okay. Awesome.
Yep. And then there's also a section where it says how many dives do you have? And what I would do is where is that? It's somewhere in here. I forget exactly where it is. But I would make sure that you add the number of dives after you added your C cards, because the way the back end system works is it goes through and auto generates those cards whenever you get a new certification or when you add your number of dives, and it seems to work better when you add your number of dives.
So add all the cards and then the dives.
Correct.
Got it. All right.
Right. Whoops. And let me get out of. Let me just share one more thing. I'm gonna, as long as I'm here, I'm gonna have a shameless pitch. So this rec. Oh, it's not letting me share. I want to show you a background. Dave, why don't you go on to a new question so I can get ready and for showing what I want to show.
I cut in quick.
Yeah.
The value. Can I cut in, Dave, or can't you hear
Yeah.
me?
No, we can hear you. Go ahead, Don.
The value of what Jim's doing too comes into play with when you're traveling. Say that you forget your passport, but you may forget a C card. They can pro check you at any dive center. So it's good even if you're a patty diver to go in and add this in and add your dives in and keep track of that stuff. Because if you get to a dive resort, you can have them pro check you instead of handing them your card.
Mhm.
So that's not a bad idea if you're not in the SSI system to at least throw it in there. That way you have a backup if you get someplace and you don't have your card.
Cool, thanks.
Yeah, Dave, I got a question.
Yep.
Can you-
Somebody had a question?
Yeah, I just got a quick question. Is that how you enter dives if you didn't enter them like on your phone or something when you're out of the country? Is that where you can enter? Okay.
Yeah. So Michelle mentioned those table questions were the ones I didn't write because you're using the PADI thing. Yeah. So here's a little history of the dive table, which we'll go into more detail on Thursday. But the Navy created the dive table by throwing basically young, white, healthy males over the side of ships to figure out how many of those will get bent to an acceptable. Don's going, yeah, like us, because we are the Olympic athletes of diving. Look at these bodies, right? So what they basically did, that's a vast oversimplification, but they looked at, okay, what would be an acceptable amount of decompression sickness, right, for Navy divers to experience while they're doing a mission, right? And so that was kind of the gold standard. And many training organizations, including SSI, still use that because most people are diving with dive computers nowadays, right? So what PADI decided to do was invest into a more recreational diver-friendly table, right? The major difference is the pressure groups, the A through Zs. Well, with the Navy table, it's A through K. With the PADI table, it's A through Z. So if you're trying to see if you're a B diver or Q diver or whatnot, it's really hard to do when A is an A and B is an B. They're all a little bit different. So that's what's going on. It's not this right or wrong or whatever, but we'll go into it next week. I forget exactly who's talking about it next week and M values and all that stuff. That'll be Bill be talking about it more. Did I just steal all your thunder for next week, Bill?
Nah, we're good.
Okay, but
There was nothing like getting on a boat in the early 2000s and saying, after a couple dives, I'm a C diver, I'm a K diver. And everybody looking at you, what are you talking about?
well, but in the real world, what happened, I have like 5,000 dives in, right? So in the early 90s, I don't think I ever saw anyone plan dives. They just blindly followed a dive master, right? Oh, the dive master's not going to get us into trouble. Yeah, whatever. Okay, I like being responsible for me.
Good plan.
Yeah.
So I had a question that really related to the topics that were talked right now about pressures, but it was something that was brought up. The argon and the dry suit. Why is argon used as the buoyancy gas and not standard air?
I can do it if no one else can. It's about the heat carrying capacity of argon. So yeah, so argon doesn't. It's simplest way to put it. Argon lets you stay warmer longer.
Okay. Yeah, I was looking at just the densities of argon versus air. I'm like, don't you want your lift gas to be lighter?
Yeah,
Okay.
that's exactly why it's more thermally. It's better thermally for you.
Okay. Thank you.
Okay, what else we got? Who wants to go diving?
Off topic.
Me.
Yeah.
Do. In the warmth.
Yeah.
Yeah, in the warmth.
Yeah, Rusty
Yeah.
and Jeff, you were in this weekend, right? What was it, 42 you said?
There.
45?
We were supposed to leave on May 2nd for Little Cayman.
Were you?
Yeah.
Well, you know, 45-degree water, Cayman water, it's the same.
Jim,
45.
why didn't you schedule Stacia like a couple months afterwards? We could have been stuck in quarantine down in Stacia.
Oh, I know.
The entire time.
Well,
think
but
timing to
think
stay
about it.
perfect.
Of all the places to get stuck, do you want to be stuck in the place that has no natural resources and they need a boat to come to them twice a week?
Yeah, I almost literally got stuck in Aruba back in March.
All right.
I almost didn't make it back. Not so fun.
But it's Aruba.
Yeah, but Aruba would have been a good place to get stuck.
Yeah, but restaurants were closing. I couldn't get into the grocery stores. Everything left. There was nothing there either.
Oh.
It was a little freaky.
Yeah,
Yeah, and in
other than
Stacia,
that,
you don't want a pandemic to hit Stacia, considering the doctor may be busy.
No.
It would actually get kind of. How many times could you walk around that island before
Right.
you're going crazy?
Hey,
Look.
Stacia had a great border customs patrol, okay?
Yes, they did.
It was a turnstile.
Yeah.
I still don't understand why we had to get out of the truck and walk and then get back on the truck.
Yeah. So this is we were talking. We had a Stacia trip back in February, right? So little teeny island. What were they? 6,000 people, 3,000 people, some
I
tiny
think it was
number.
3,000
people.
Yep.
Right. And so there were 2 dive shops on the island. One was actually like diving, and the other one I think we saw it one day. I think, right? So they put you in these little this like pickup truck, and they bring you the quarter mile down to where the boat's kept. But before you could get there, you had to get out of the truck and you had to pass through customs. Even though you were still diving in Stacia and you were staying in Stacia, you had to clear customs. And customs were, you got out of the truck, you passed through a turnstile, the truck went forward 20 feet, you hop back in the truck and you went forward. Every single dive, that's just how it was. This is very odd. And they would come out and they would write the license plate number down. They might as well just said 1.
It's that truck.
Or 2, it's that truck. Yeah. It was just a very odd system. But what I thought was hilarious is, so you have this marina area, right? And there was like barbed wire fence around and all that, and just stopped to the water, and you could just like walk around the fence because the fence stopped to the water. You could get your feet wet and you could break their whole like customs system there.
Yeah, because there was that beach right there, and the people were swimming on the beach.
Yeah, right. So
Yeah, and then coming back from the dive, you had to go through the turnstiles the other way.
right.
Yeah. Yep, same thing.
No, you're forgetting you get to wave to the custom officer too as you pass.
That's right.
Right, exactly.
There's that too.
Right. So Lear has a very, very good question. So for all the instructors, what's your favorite specialty class to teach? I think more importantly, why? All right, Don, you're first.
Deep.
Why?
Why? It's cold. I can't even begin to guess which one.
Right.
I don't know.
All right, Dave, to you next.
I'm going to go with navigation.
And you're very good at it.
So how many years of scouting do you have in your experience, Dave?
Since what? 98.
So how many scouts in your life have you taught to use a compass?
I don't know.
Yeah. Hundreds? Are you past hundreds? So
It's just, navigation's a fun one because, we start on land and we kind of do some things there, but then we move into the water and, being able to confidently get back to where you started is a really good skill.
Mm-hmm.
I've never
we let
seen.
you lead us up the mountain.
Right.
Or volcano, sorry, not mountain.
My problem is I get distracted. I'm really good in the beginning with the compass and I'm paying attention, and then I see a fish or.
Right.
And the current can throw you off too, right?
Yeah.
Well, and Pat, if you follow the turtle, you'll never get lost.
That's right. I will.
Right. All right, Joe, you're next. Which one?
I photo video because, like I said, I like being able to capture the moments to be able to come back and look at them later. And I could also share them. As I find out, there's an awful lot to video. There's a lot of getting your buoyancy right. So there's a lot of different elements, trying to get the light and, again, being patient. It's just, but, being able to capture what you see underwater and be able to share it with people, I find that enjoyable. Be able to post the pictures and have people that may never have seen that or had the opportunity to, kind of see there's more to the world than what's above the water line.
Right, cool. Megan.
Probably going to be React Right. Just because a lot of my background is in emergency first response and being able to teach people this is what you need to do to keep somebody alive when something bad goes wrong, until someone else with a little more knowledge and experience can get to you to help.
Well, that's cool. Rusty.
Oh boy, I like doing deep and stress and rescue. I like doing the stress and rescue because the role playing that takes place on the boat. I think it's.
So you're into role playing? Is that what I'm hearing?
Yeah, I'm
Okay.
into role playing, but you know what I mean. You get to practice doing a rescue and different scenarios, and it's fun. It really is.
DJM.
Yeah, I'd say perfect buoyancy. It's kind of that's the core. I think the core skill, and I can always get better at it. And I like to get in the water and teach that. The other one I'd add, and I haven't taught it formally yet, but the marine ecology and some of the other specialties. I spent the 80s out in San Diego, living on the beach, and went to college out there. Took some oceanography, and you know what? It just an incredible class because I could go out and live it every day and go see what it was on the beach. And so the ecology piece is pretty important to me and quite enjoyable.
And you have pet dolphins, right? Like that's right behind you?
Pet dolphins, exactly.
Yeah. Exactly. Mr. Fitzpatrick.
Dry suit, definitely, because of where we live. Most of my diving background is in warm water, and then started diving with you folks. There's a lot of cold water up here in the north, and dry suit you can pretty much year round. Daryl and I have been trying for months now to get diving. Now with COVID, kind of haven't really got a chance, but dry suit would definitely be the my choice, so you can get that year round diving in.
Right. Yeah, it's one of those things with COVID. Yeah, you can figure out how to get in buddy pairs, and one person can go in a bit. But what happens in an emergency? Taking that regulator out is, that's where it gets interesting. All right, Nick, what about you?
Take it out.
You got to do it a petty and give him the other one, not your.
Yeah, right. Well, just the closeness and all that, All right, Nick.
Yeah, I'd have to go with deep. A couple reasons. One, I like deep diving. And two, it's the only specialty I've formally taught so far.
Oh, well, there you go. There you go. And then, Gene, you still on?
Of course.
What about you?
Well, have to be boat diving, the videography, and deep. And, I like to throw in night diving there, especially if you come up the Adirondacks. Again, at high noon, you can do deep, cold, and night dive all at the same time.
Have you ever thought about opening a dive resort up there? Because, boy, that sounds great.
Oh, I'm sure there'd be just flocking up there to do that.
There'll be ones of people who want to go.
Hey, if you time it right with the months, people will be diving just to escape the mosquitoes and flies.
There you go. And by the way, about the air sharing, that's a really simple thing to do. You take the regulator out, you put the Germ-X on it, rub it for 20 seconds, and then give it to your person
There
who
you
just
go.
drowned. I mean, to the person who needs air.
Right. Yeah, it's like, okay, out of air, share air, and you're like, hold on.
1 minute, please.
Hold on. Breathe out, okay. Yeah. For me, it's the Dive Pro classes. So starting with Dive Guide, mainly because you see growth in people from when you come in as a recreational diver and you start focusing inwards, right? So as people get trained up more, right? So at first it's a lot of inward stuff with open water diver. Then you start looking outward and you start doing things like Joe was talking about. You start using cameras and all that. The Dive Pro classes, you see the personal growth in people, right? So for those of you who are dive pros, think about where you were like 5 years ago or 5 years before you were a pro or whatever to where you are now. So, yeah, for me, that's really rewarding to see the personal growth in people.
That and you like to teach the travel class. You're teaching us all how to be good travelers.
Exactly. Exactly. So, okay, what else do we have? I think that may be it.
Hang on.
Oh,
Oh,
there it is.
There is the security of station.
Customs.
Yeah.
Customs.
That's going back in.
Yeah.
Right.
That's re-entering the country.
That's the border
International
patrol.
line.
Yeah.
And our car's right next to it. You can
Yeah,
see
that's-
them in the back.
Yep.
That's the car.
Yeah, the little flatbed.
That would
Get
be
off, walk through
Captain
there,
Mark
get back
getting
on.
cleared.
Now, this was taken at great risk by David. I mean, the security was so top notch. He had to hide that.
I had to hide under my backpack.
Right. But the thing that always gets me, literally, they have 2 trucks. They're there 3 times a day. Someone comes out, goes around, looks at the license plate, writes the license plate number down on a clipboard. Yeah. Anyway.
And it was the same group of people the whole week. Although we
right.
did dwindle as the week went on. People were getting sick, but
Yeah. So.
Are there any specialties you guys are interested in? Because we're kind of setting our target right now on putting together a plan for what else we could offer, but would certainly like to hear from you guys.
I want to do the fish ID one so I know what fish I'm
Fish
looking
ID?
at.
Yeah, I'm thinking the fish and the coral maybe, as well as the equipment techniques. But I want to see what that would be about, since you said that that'll be discussed like next week.
I'm thinking the perfect buoyancy and the React.
Cool. Hey, I'm gonna make a little plug for something I'm working on. I'm gonna start sharing. I was able to pull it up. So you may or may not know that NOAA, National Oceanographic and Atmospheric Administration, has proposed a Lake Ontario National Marine Sanctuary. Right. So this is their webpage. Right. This is a webpage. So I was lucky enough to be selected to be on the advisory board, representing the dive community. That wreck that's on their front page is the St. Peter, which I'm sitting about 2.5 miles away from right now. And we visit all the time. And so there's, in our part of the lake, right, there's quite a few wrecks. And most of those, unfortunately, are in the middle of the lake down at 400 or 500 feet, right? But the idea with the Natural Marine Sanctuary is that all of these wrecks will be videoed. There'll be an interpretive center, and most importantly, they'll be preserved. So, today and for the last, I don't know how long we've been throwing buoys on the St. Pete, 12, 15 years, something like that. They're going to be maintained properly with proper buoys and all that, instead of the stuff that well we do, right? So there's the St. Pete again. So we're starting up in earnest. The first meeting was last week, but there's going to be more and more community outreach. The plan usually takes about 3 years to work its way through, and we're beginning the beginning of the second year. So in about 2 years from now, we're hoping that we have a National Marine Sanctuary. One of my ideas is to expand it up to the Thousand Islands as well, because I see what the Canadian side of the river has done to attract tourists, and most importantly, to gain access to water. There's changing facilities they put in, there's signs, etc. I'd like to see all that on the New York side as well. So keep your eyes and ears open. We're going to be doing a lot of outreach through local media and print mechanisms, but it's something that I'm pretty excited about. So once again, we're hoping in about 2 years or so that we can have this this completed. So
there's funding for this project right here?
Before COVID, there was funding for it. Right. So the idea is that there's such a small percentage of budget. It's something like $220,000 a year. A very, very small amount of money in the budget. So NOAA has there's I think they have 18 ships in their fleet, and they're all relatively new, so their big capital items are not needed. Right? There's a couple like older ones, but that's very specialized. But so they're not asking for, hey, we need 500 million for a new ship or anything like that. So I'm guardedly optimistic that this is going to go forward. So
We were in the middle of the instructor trainer course when the NOAA people showed up at the Pulteneyville Historic Society, right?
Yep.
And we got to meet them, and they were like doing drone coverage of Pulteneyville, and the divers were out on the wreck, and they were filming. And somewhere on that site you showed, Jim, there's a complete like 3D model of the wreck.
Yeah, that's what I was looking for. It's I always forget where it is. It's not well hidden. And one of the things I asked for was any of the 3D work they put together. Excuse me. Let's make sure that people can print 3D models too. Virtual dives, there they are. So these are all over the various sanctuaries. We may not be officially published yet. They have these 3D technologies, kind of cool. You know, those little viewers that you can get, so you can actually walk around or swim around. It is someplace else, which I don't remember. I can find out more if it's something that interests people. I can find out more about it, but where it is, but I don't remember off the top of my head. But anyway, so I think it's a pretty exciting product or project, and what I'm liking about it is it's not just about diving or just about history, right? They're actually bringing in tourist organizations, right? So there's like landowners that are represented, so it's a wider swath of people. And so the idea is, if you look at where the sanctuary, the bounds of the sanctuary, Wayne County line, all the way up to the Thousand Islands area. At least we want to extend it some more. So this is an area down in here that doesn't have a lot of economic development, right? So this could be a way if we get some of these shipwrecks buoyed, to have a little more economic development. And then it frees up a lot of the advertising and marketing dollars, so that if there is a dive show or an outdoors person show, NOAA can help fund that. To have more exposure for this area, which is, I think, pretty cool. So anyway, just wanted to share that.
Cool. Jim, we have interest. Can you send a link out to everyone on that one?
Sure. So did I not share my screen? Because all of a sudden
No, you did.
Okay, good. Okay.
You did.
Oh, there's the stop share. Okay. I will send a link out.
Okay, well, hopefully everybody got something out of what we delivered today, and we get 3 more chances to get more to you. So if you got questions in the meantime, I didn't mention that on the last slide, but dives@ruforscuba.com, just email that address, and Jim is handing them out to all the instructors as the questions come in, and we'll take care of you.
I have a quick question, if I could, before we leave.
Sure, Bert.
So Patty and I are new divers. We only have 10 dives under our belt. We're going to Bonaire in September. How do we log and get our dives certified out of the country?
So there is a SSI shop on the island. And most of the dive sites that are on the island will be in the SSI database, right? So if you have an international data plan, it's really easy because it's going to come up and you can pin where you are and say, yep, I was on the Hilma Hooker or whatever it was. But if not, you can always enter that later. We were thinking about that once we're finished up with Science of Diving, maybe we'll just keep these things up and we'll do how to use the SSI app to log your dives.
That would be good.
That kind of thing.
Where are you staying in Bonaire?
We're cruising to there, and Jim's setting me up with the dive shop there. So we
VIP divers.
with them. So they're going to meet us and then take us to where we're going to go, I guess.
Great.
Your buddy.
If you get a chance, if they're still around, there's a sailboat called the Compass. Takes off and goes out. Oh, the sun is getting close to setting. Drinks, you go a little snorkeling, dinner, come back after dark, watch the sun go down, see the mysterious green flash. It is really a lovely evening. The Compass, if it's still there.
Yeah, we leave at 5 p.m. We get there at 8, so we're diving all day, and then they're going to bring us back to the ship at 4 o'clock or so.
Yeah, you're going to have a lovely romantic cruise with you and 5,000 of your friends, right?
It's all right.
Hey, my suggestion would be if you got your own, do you have your own dive gear you're taking with you or not?
We have our own dive gear. We when we started diving, we were all in. So we have all these state-of-the-art stuff.
Well, the thing I would recommend, I found real beneficial, was if you got some kind of hard-soled, booties to wear. The Iron Shores, they're brutal on the feet, so I picked up some kind of hard-soled, booties. And boy, I'm so thankful I got them for Bonaire.
So would our great scuba shop have those, Jim? Hint?
I know how to order those.
Did you?
You won't regret them.
Your feet.
All right.
Okay, is that a wrap?
Our work is done.
So
Right.
Thursday, we'll do it all again. 6:45, we'll start the meeting.
Oh,
and,
so I just one thing. Charles had one question
Yep.
here. So
Oh,
for those
sure.
that finished online, do you need to do anything else to get the cert? So like I said, these are just supplemental sessions, that we're reviewing things, and there's a social aspect of things because we haven't seen everybody, in a while and all that. So strictly speaking, no, as long as the final is completed, right, you're good. But if you want to hang out, physiology Thursday, then remind me, Dave, the other two things.
Decompression theory Tuesday.
Yep. And
Yeah,
then
and
equipment
the
Thursday.
equipment stuff is on Thursday. Yeah.
Right. So strictly speaking, no, but we hope to see you Thursday.
Thank you.
Okay, and if you guys have any
Thank you, guys.
suggestions, let us know. Have a
Yep.
great night.
Thanks, guys.
Thank you.
Bye.
All right, take
Thank
care.
you. Have a good night. Thank you.